In some applications, we want to design the load such that the power delivered to the load is maximized, or we can say the power extracted by the load is maximized. Thinking about a circuit in the radio that this is the speaker, and we want to design a speaker such that the power delivered to the speaker is maximized. So how do we find the value of the load RL such that the power is maximized? We know we can simplify a circuit using deafening theorem where VTH and in series of RTH here. So now let's look at the power on RL. The current goes through RL equals to VTH divided by RTH plus RL because these two resistors are in series connection. The power on RL is I squared multiplied by RL. So we plugged it in. Let's look at the curve of P with respect to RL. The x-axis is the value of RL is changing from 0 to infinity. And the y-axis is the power on the RL. So when RL equals 0, of course, the power will be equal to 0. And now when RL increasing, the power is increasing until it reaches RTH. Then the power start going down. So when RL goes to bigger and bigger, goes to infinity, actually the power goes to 0. In the extreme cases, RL goes to infinity, RL goes to infinity, which is open circuit. Of course, in that case, the power on RL will be equal to 0. Now we can see from this curve, the maximum power happens when RL equals to RTH. RL equals to RTH. This can be proven mathematically. We take derivative of power with respect to RL. So remember, VTH is given, RTH is given, RL is the variable. We take the derivative of the power with respect to RL, and then we set it to 0 and solve the equation to obtain the value of RL. Take the derivative of P out, so that's this value here, that's exactly this value, and take derivative with RL, set it to 0, and solve for RL, and RL actually equals to RTH. We're not going to go through the detailed derivations, but here is how mathematically prove that RL equals to RTH, and at that condition, the maximum power will be extracted for the RL. So now what is the maximum power? Maximum power at the RL. This is the power on RL. RL now equals to RTH. RTH, that's RL. Perform a little reorganization. The maximum power on the RL equals to VTH squared divided by 4 RTH.